In the next few videos, we will review some basic fraction algebra, and we begin with how to find the LCD, also known as the least common denominator of two fractions or more. The steps are written down over here in case you forget and in case you want to refer back to them, but I will explain with an example. So example 7 says, find the LCD, which means find the least common denominators of the fractions or the given expressions 13 over 36 and 11 over 90. So what I'm going to begin with is extract the denominators 36 and 90, and I'm going to break them down as much as possible. This process is called the prime factorization. So think of a way or numbers to multiply to get to 36. So, there are different options. I can think of 6 times 6. 6 is not prime, so I'm going to keep breaking it down until I get to the prime numbers. Once I get to the prime numbers 2 and 3, I'm going to circle 2 and 3 because they are both prime. Same thing again with the other 6, I can write 2 times 3. So in other terms, what I'm saying is that 36 is the same thing as 2 squared times 3 squared. So I'm done with the 36. Let's go back to 90. One way to write down 90 is to multiply 9 and 10. 9 itself is 3 times 3, and both of those are prime, so I'm going to circle them. And finally, 10 is 2 times 5. So another way of saying 90 is to write down 2 to the power of 1, 3 to the power of 2, and 5 to the power of 1. So where am I getting these numbers from? So the numbers, for example, 2 is the base, so I'm writing it down. And then the number 3 is, for example, showing up twice, so I put 3 to the power of 2. Then finally, the number 5 shows up only once. It's only circled once, so that's the reason why there's a 5 to the power of 1. Similarly, I did the same thing on the other one. At this point, we are about to make the decision on the LCD, so we're going to look at the first result that we got, and I'll put a red box around it, and the second result that we got, I'm going to put a blue box around it. So the first things first, what are the bases that will show up in the LCD? The bases that show up in the LCD are every base that you saw in the prime factorization. So every number that you saw shows up in the prime factorization. We write it down in the LCD. So 2 shows up first. I saw 3 again, so I'm going to write down the 3. I see 2 again, but it's already been written, so no need to write it second time. Same thing with the 3, and 5 is brand new. I haven't seen it yet written down, so I'm going to go ahead and put it in the LCD. So those are the bases. Once you figure out what the bases are, you have to figure out what the power must be. And for the power, typically what you want to do is pick the highest possible power you can find for the base. So for example, the 2 in this problem has power squared and power 1. We take the higher one of the 2, which is the square, and we write it down on the LCD. So it's going to be 2 squared. Same thing again with the 3. The 3 has power 2 on the first try, and the second has a 2 also. So they're both 2, so it doesn't matter which one you take. I'm just going to take one of them and write it down in the LCD. And then finally, 5 has the highest power in this problem, a power of 1. So that's going to be written down over here. And basically, this is it. So another way of saying this is to say 4 times 9 times 5. Or you can also multiply it out and see what you get. So that's basically how it works when you have simple numbers, but the same process could be used to find the LCD of more complicated expressions. Now, once you find the LCD of expressions, your next task is to form equivalent fractions. Why would we want to form equivalent fractions? And what are equivalent fractions in the first place? Equivalent fractions are fractions that are equal when you break them down and simplify them to lowest terms. That's what it means to say equivalent fractions. For instance, 4 over 12 and 8 over 24, when divided out, they're both equivalent to 1 divided by 3. So they're both equal at the end. So typically speaking, we want to find equivalent fractions when we're adding or subtracting fractions. So this is the reason why we're doing this task right now. So we're going to start with the first example. It says 17 over 60, and they want us to write it as an equivalent fraction with a denominator of 180. So what we want to do is put a 180 down here. So it's a pretty straightforward, simple, way of doing things. What we have to do is think about how did they go from 60 to 180? What did they multiply 60 by to get 180? And so they multiply by 3. So therefore, we have to do the same thing with the numerator. Take the 17 and multiply it also by 3. So it used to be 17. We're going to multiply it by 3. And whatever result we get is going to be written down on the numerator, and the denominator is still going to be 180. So in this case, I get 51 over 180. And as a matter of fact, this is the answer. We're not going to worry about breaking it down and dividing it out. If we divide it out, it would become 17 over 60, but that's where we're going to stop. Same thing again with the second one. The second one says 216 as a denominator. So we want 12 over 36 to be rewritten with a denominator of 216. So what you want to do is figure out what you multiply 36 by to make it 216. In this case, you have to multiply by 6. So again, repeat the same process on the numerator. 12 gets multiplied by 6, and you will end up with 72 divided by 216. So we say that 72 over 216 is equivalent to 12 divided by 36, because if we put them in the calculator and divide them all out, the result will be identical on both.